Hi, and welcome to the third issue of Stunt Flyer Video Magazine. We're coming to you this time from the editing suites of Robin's View Productions, where Stunt Flyer Video Magazine, as well as all of the other videos in our catalog, are produced. In fact, I was just working on one of the segments for this issue. It features Mike Spedalier showing us all the tips and techniques on how he achieves the beautiful transparent finishes on those stunners that he always shows up with. Mike's going to show us how to achieve extremely tight wood fits, how to install balsa wood fillets, and how to apply seamless dyed silkspan covering jobs. Also with us this issue is Dean Pappas, and he's going to complete the discussion on blowdown timing that he started 2 issues ago. Dean's going to show us this time all the math required, and he's going to lay out and grind a liner for a model airplane engine. He's also going to show us how to deburr it properly to prevent damage to the piston. After that, we're going to head to Indianapolis, Indiana, and visit with John Davis. John, as many of you may know, has a very extensive collection of old stunt ships from the 1950s and early 60s. The collection includes one of Jim Solhavy's Noblers, one of Bernie Ash's Airons, and I believe even one of Roland McDonald's original Strathmore Stunners. It's pretty interesting stuff. Well, we have a lot to do and a long way to go. Enjoy. We're sitting here with Mike Spedalier, and we're looking at his beautiful Professor, which is the second in a series of Professors. Mike, welcome to Stunt Flyer Video Magazine.
Pleasure to be here.
Mike, I met Mike, I'm not sure exactly what year it was. It was 1989 or so?
About 89, 88, 89.
89. I was judging a contest at the Garden State Circle Burners, and this fellow showed up with this very high aspect ratio, clear finished airplane, very radical design from what I was used to seeing. And he got ready to fly at the infamous Garden State Circle Burner field, which is noted for heavy turbulence. That's an understatement. And characteristically, high aspect ratio airplanes don't do well in turbulence. And I expected him to have a lot of trouble. But he surprised everyone there. I think it took second that day, didn't you? In advance. And the airplane flew flawlessly through the turbulence. It didn't have any rolling or banging tendencies. And I did something I rarely do, which is to ask, at that time, a complete stranger to fly his airplane. And you let me fly it. And it in every way, it did fly well in turbulence. And that was because it was built very, very light. It was very, very straight. And that's been a hallmark of your building, is excellent craftsmanship and attention to detail and attention to weight.
Thanks, I appreciate that.
Yeah. Another thing that's a hallmark of your work is the fact that you use transparent finishes on your airplanes.
Correct, I do.
Yeah, and you combine that with areas of opaque finish here. It's obvious you've been building for quite a long time. Tell us a little bit about how you got started in model airplane flying.
Well, when I was younger, I flew with my dad, and he basically got me started in building and flying. And we kind of got out of it as a family when I was younger. And I got back into it. Strangely enough, I found 2 model airplanes in the basement of a house that I moved into, and it sparked it again, and I got back in, started building rubber scale, and then back into full-size stunt ships again.
Well, certainly you made a mark here. This is really impressed me and a lot of other people as well. I remember when you showed up with your natural, which unfortunately we don't have here tonight, but you showed up with that and it set everybody on their ear. That was, I remember it placed very, very highly in appearance at the Nationals. And
second row at the
Nationals for a clear finished airplane. That's saying something. Could you tell us a little bit about some of the aspects of the clear finish, some of the things that are important, and some of the things you have to consider when you're building, so that you know when you get to the finishing part you're going to have a good-looking product?
Well, I'd say the 2 most important things are wood fits naturally, so that you don't have any glaring mistakes showing through your finish, and the other is choosing your wood grain so it matches and it's clean looking. You don't want to have any big areas of knots or really crazy grain or anything like that. You want it to look as clean as possible, so when you do put the transparent finish over it, it looks as smooth as possible.
Suppose you have some wood that you just simply have to use because it's light and it does have some knot holes in it. What would you do then? Try to hide it under the opaque finished areas?
Yeah, if you look real closely, this one flap, as a matter of fact, has sort of a knotty area in it right there, and you can do a couple of things. You can make sure it's strategically placed under the painted trim, or use panel lines to kind of disguise it a little bit, and the same type tricks you would do on an opaque finish that had some bad spots in it.
Well, I noticed too that this airplane has something that I've never seen on a control line stunt ship before. I've heard about it, but I've never seen it until I saw your airplanes, and that is balsa wood fillets.
Yeah, I started doing that on the natural, as a matter of fact. The original professor had epoxylite fillets, but when I did the natural, I really didn't want any paint on the airplane at all, so I chose to do wooden fillets, and I experimented with about 150 different methods to do it until I finally came up with one. And actually it's not as difficult as it looks, but I really wanted to keep that natural wood effect, and that's really why I came up with them.
Oh, it sure is effective, and it's a little thing that really doesn't fall to eye readily, but when you start looking over the airplane, you realize that, hey, these fillets are different, and they're transparent, and they're actually wood grain, and they blend in so well with the rest of the airplane that you really can't even see the seam between the fillet and the fuselage unless you look at very, very carefully.
Mm-hmm.
And that's another thing too. Your wood fits, like I said before, are impeccable. There's places here in this fuselage where I can't see where the balsa side and the top block seam is, and I also can't see the seam in the tissue covering.
There's a couple of tricks that I have for all that, which we'll demonstrate on the tape, and it's just taking your time, period. It's taking your time and making sure that everything's done right and step by step, and it's time and patience. That's the biggest key in getting your wood fits to look like this. And you can't really afford to have any gaps and wood fits for two reasons. One, it makes your airplane a lot lighter if you can get away with less glue. And the tighter your wood fit, the less glue you have. And secondly is your appearance. You keep it as clean as possible, and it'll look good every time. You don't have to paint it.
Well, it sure is a neat technique. I'm going to get out of your way now and let you demonstrate a little bit about how you do the tight wood fits, what procedures you use to get those wood fits. And you actually have built some really neat looking little demonstration devices here that are actually better looking than some of the airplanes I've built. So I'm pretty impressed with what I'm seeing here. We're going to get out of your way, and we're going to let you tell us how to put in balsa wood fillets and how to make tight wood fits.
Okay, let's do it. Okay, what we've done here is built basically a mock-up of a section of fuselage from a built-up stunt ship. And I'd like to show you how I get my glue joints as tight as I do. Two things I'd like to point out here. When I tack the block to the top of the fuselage to shape it and form it, I don't tack on the outside edges of the fuselage sides. When you pop the block back off to hollow it out, generally there's, as you can see on this, there's sections of wood that are left on the formers. It'll do that on the fuselage sides, and it'll create little nicks along the side and chip it. And I like to preserve that edge so that when I glue it, it's nice and clean and straight. What I do really is, it's not a big secret. I take a little water and I basically wet the edges of the fuselage sides down a little bit. And what this does is it softens the wood, and it lets it swell a little bit so that the joint becomes tighter as it dries. And just run a little bead of water. You don't want to soak it, just get it wet enough so that the edge is just kind of soft and pliable. And naturally this top block would be hollowed out before final gluing. But we do the same thing with that. Just run a little bead of water down both edges. And then when I put the glue on, I generally thin the glue a little bit, about 70-30 glue to water. And this delays the drying a little bit, and I think it makes it a little stronger. And also the little water in the glue helps to keep those the edges of that fuselage wet, or wingtips, or whatever you happen to be gluing at the time. Oops, a little spill there. And then you just, like you would normally do, just set the block in place. Now you want to push down with a little bit of pressure so you see some glue squishing out the side. Just wipe that off with a paper towel. And then use your masking tape to hold it down. Like I say, you want to push down with a little pressure now and make sure that the wood, those soft joints, you push them together and they're a little bit pliable. And you'll see when it's dry that the joint comes out pretty tight. And that's it. We'll set this aside to dry and take a look at it later on. Okay, next I'd like to show how I do the wooden fillets that Bob mentioned previously. It's really quite simple. It's a little time consuming, and like I say, patience is everything, especially in this step. What I've done, I've drawn a template of the root and the flap fillet connected to it so that we can trace and cut our fillet from that template. Basically, I just use a piece of hard 1/16 balsa and I reinforce it with a little hot stuff, and it makes quite a good template because you're not really going to use it that much. The next thing I do is I go try to find a real nice, light, soft piece of wood. I like to use real soft wood because it's a little more pliable and it's easier to form when you get down in this area and around the front of the leading edge of the wing. What I've done is I've drawn an outline, one outline of the wing root and the flap fillet connected. Then I take the template and I slide it down only about 1/4 inch. And basically I slide it down and over a little bit so that the leading edge is exposed. And you'll see the shape of the fillet, really, what it's going to become your fillet later on. And I draw a pencil line just on the outline of that. And then when you lift the template up, you'll actually see like 1/4 inch what's going to become your fillet later on. At that point I take an emery board or a sanding block or even a piece of sandpaper, fold it up, and I basically cut of a 45-degree angle in the edge of this piece of wood from the edge till it touches that pencil line that you drew. And that'll give you the basic starting shape to your fillet. The next thing I do is I take the template, I lay it back down right on top of the line that we drew previously, and basically cut out your fillet. And try to cut as straight down with the knife as you can, and I'll show you why later. And as you can see, basically we have a fillet. It doesn't matter if you let this edge continue on down like that. Leave it as long as you want, because you're going to trim it to basically the center section of the wing, on the center line of the wing, rather, after you're done gluing it on. You just lay it on your wing as a trial fit and see how well you matched up the template. And this isn't too bad. And you can see how it fits right in the joint like that. The next thing you have to do, which is an important step, and this is a little tough to handle, but you have to get back on the corner that's going to be seated right in the wing fuselage joint, because there's always some glue that builds up in this joint right here, and if you leave that edge real crisp, it's not going to seat and it's not going to be a real tight joint. So you have to get in there. This is probably the most time consuming and the most ginger part that you have to do. You have to take a sanding block and just support it with your finger as you go along. And you have to radius that down so that you have some open space between the fillet and the fuselage wing joint. So if there's any glue buildup there, it's not going to push the fillet away. Oh, I think I broke my fillet back here. That's okay, though, we still have plenty left. This always goes better when you're not showing somebody what to do. And you can use a dowel for this area if you're more comfortable. I just take a piece of sanding paper and roll it up. Now we have a little radius in this back inside corner. So then when we glue it onto the wing here, there'll be a little room for any glue buildup that's down there inside the wing fuselage joint. And you can see that kind of fits pretty tight right there. Okay, next we're going to show how we basically attach the fillet to the fuselage wing joint. What I like to do first is basically the same thing we did on the fuselage and top block with a little thinned out glue, wood glue. You just want to coat the wing and fuselage with just a thin film of glue, and the thin glue does help. Also, the water in the thin glue works just like it did on the fuselage block, the top block, and it makes the wood swell just slightly, and it makes the joint a little tighter. So just go along. Make sure you get a nice even film. And then we're just going to press our fillet into shape. Now what I like to do is I like to go along, starting at the leading edge, and just in a few areas, take a little hot stuff and just tack it with a real small drop of hot stuff. You don't want to use a lot, because then trying to sand it later is going to be really difficult. Let that kick off. And just work your way back about every 2 inches or so, inch and a half, and a very small drop, just a little bit. And I put the glue up on the fuselage side of the fillet so that it's holding the fillet down into the wing joint. Just let it kick off. press it into the joint as hard as you want. You could even wet this fillet a little bit. The hot stuff will still work. It makes it a little more pliable, but if you use a real soft piece of wood, it generally goes pretty smooth. Move my finger there. One spot you want to make sure you tack is right at this low point where the trailing edge of the wing meets the flap fillet. So you want to hold it nice and secure there. Like I say, real small drops of hot stuff. Just enough to hold it in place. And there you have it. Basically, that's exactly how all 4 fillets will go. After it's dried, and you're going to do the bottom half of this fillet, you'll trim this off just at the center line, the leading edge, and then glue your bottom one on so it meets it in the middle. And then you'll just sand it and form it as you would any other fillet. Just take a little dowel with some sandpaper on it, or a piece of, I like to use a piece of balsa wood with a radius sanded on the end, because you can kind of get down in there a little better and sand it. And basically the finishing is just like any other fillet after that. Okay, next I'd like to go over one of the things that is kind of important when you're covering an airplane with clear covering, or just dyed silk span or silk or anything transparent. And that's the joint between 2 pieces of silk span or silk or whatever the covering happens to be. As you can see, our top block's pretty much dried up, and it's a pretty good joint there. First thing we want to do, like in any covering process, is give the glued edge a good sanding so it's nice and smooth. I like to use as long a block as possible so that I keep a nice straight edge and we don't get any dips and little whoop-de-doos in the fuselage side. So we'll just go ahead and give this a sanding. You want to go along with your hand and feel if that joint is protruding anywhere, and you want it to be nice and flat. The fuselage sides want to blend nice and smooth into that top block. So, and a lot of times you can see better with your hands than you can with your eyes. That's getting pretty good there. The other side. Okay, now that we have nice smooth sides, basically I pre-doped this with a couple coats of dope before we got on camera. The next thing we want to do is we're going to prepare our fuselage for covering. This has pretty much all been doped and sanded down nice and smooth. We want to prepare our covering material. I pre-cut a couple of pieces of red silk span here that was been dyed with, just dyed with regular RIT dye. And use the instructions that's on the bottle. That's all I do. There's really no secrets. You just follow the instructions that's on the bottle, and it comes out pretty good. Don't worry about it if it shrivels all up and shrinks, because once you wet it to put it back on the fuselage, it'll smooth right out. First thing we do is we want to just give our first piece of, clean some of this sawdust off here. Want to give the first piece of silk span that we're going to use. Oops, got a little sawdust on there. And just dampen it with a little water, like you would do if you're covering with silk span without the dye. You don't want to get it too wet, just a little damp. Next, you're just gonna, like I said, this is really not much different than covering with, you know, regular silk span. We're gonna do the joint right down the middle at the top so that you can see how I do the butt joints. Another reason why I don't wet the silk span too much is because we don't want it to shrink a lot after we apply it, because that's when you see the separations in the silk span, and you'll see the wood showing through, especially if you dyed the silk span a dark color. The lighter wood shows right through in the seam, and it just looks terrible. Okay, now that we got a nice coat of dope on there, we're going to take our silk span and just put it on like we normally would. And you want to overlap the area that you plan for your seam. If your seam's going to be dead down the middle of the fuselage, you want to overlap it by like an inch or so. Maybe a little less, a half an inch. Get your silk span nice and flat. Get all the wrinkles out. Now this will be going over an entire fuselage, so it's going to be a little trickier than just doing this nice straight mock up here. But just take your time and you can work all the wrinkles out. It's pretty easy actually. If I can do it, just about anybody can. And then we'll just give it a coat of dope to seal it down. And just dope up just a little bit past the edge that you're going to use for that seam. If you see any wrinkles after you've doped it, you can pretty much work them out with your fingers. Pull the edges and just smooth them out with your fingers, and you can get it nice and flat. You want to try to get all the wrinkles out now, because once you've really got a wrinkle in this, it's difficult to get it out after you get the airplane covered. Okay, and we'll just have to let this dry up a little bit. Make this a little easier to handle. Okay, now we're going to go to the other side. Now you want to leave the edge on this initial piece, because you're going to overlap the first one. The second one's going to overlap the first one, and then we're going to make our trim and peel off the excess from underneath, and I'll show you what I mean by that one as we go. Okay, one of the tricks that I do is I let the dope dry, the first coat dry almost all the way till it's just tacky underneath. It's going to feel dry to the touch on the outside. And the reason I do that is because when I make my cut, and I cut both pieces of tissue at the same time, and I peel out the one underneath from the first piece of silk span we put down, we don't want the silk span to shrink much more and separate. So I let it dry almost all the way before I make this cut. Right now the silk span's pretty much dry. It's just dry to the touch, and you can still feel it's a little tacky, just slightly. And the other thing is, that's another reason why you don't want to wet it too much. If you wet it too much, it will shrink a lot more. So I just kind of make it nice and damp and enough, just damp enough so that it's workable on the airplane. And what we're going to do is, there's some areas you can use a ruler to make a nice straight cut, but it's not always possible, and it's not that necessary because you're cutting both pieces of silk span at the same time. So whatever cut you make, both pieces of silk span will follow the same cut all the way down the line. So we'll see if we can get this to work right now. And you don't want to cut too deep, just deep enough to make the cut on both pieces of silk span. And I'll show you what I mean by peeling off the one underneath. So it'll give us a little more, some working room here. Now basically what I do is we'll lift the top piece that we cut off first. And then we have to just peel back the upper portion just a little bit. And sometimes it's a little tricky. You have to get a pair of tweezers or a little razor blade, and you grab the piece that's underneath that you cut off of the first piece of silk span you put down, and you just peel it out from underneath like this. And then when you put the other piece down, you don't want it too wet. This is the reason you don't want it too wet, because it'll shrink. And you can still move it around with your fingers a little bit and just flatten it down and let the dope dry real well. And as you can see, you have a nice clean joint. You can't see where one piece of silk span meets the other one. If it overlaps, you'll see a dark area. If it separates, you'll see a white area. So you want that joint nice and clean. And as you can see, this is the best way I've found to do it. One of the ways I like to practice my covering and building skills is to build some of these little stick and tissue models. They're really quite fun, and they teach you a lot about building and covering and finishing, and also very lightweight. You really have to pay attention to your glue joints on these airplanes, because too much extra glue, even a gram, is too much weight on some of these things, and it will affect the flying. Your covering skills have to be nice and clean. Any excess tissue also adds weight, and it's offensive to look at on some of these things. The cleaner the better. And there's a certain romance to seeing your airplane flying overhead with bare bones, so to speak. And it does help your covering technique, like I showed in the video with the top lock on that airplane. A lot of the same principles apply to this. You don't want too much shrinkage out of your covering, and you want all your butt joints to be nice and clean, and it really does make for a nice looking model. That's about it, I guess, on some of my building techniques. I'd like to thank Bob and everyone here for giving me a chance to show my stuff, and we'll see you again next time.
The raven-haired youngster at the left in this picture is John Davis of New Palestine, Indiana, which is just a stone's throw away from Indianapolis. The gentleman at his right in the picture is his dad, who started John off in the sport of model airplane flying. Those who have been at this sport for a while will remember John from his earliest competition days when he competed, very successfully, in the Air Youth State Champs program with his Charles Mackey designed Hummingbird. John grew up in a hotbed of stunt activity and was a member of the very exclusive Indy Stuntmasters Club. His talent was quick to emerge, and he's been a force in the stunt world for over 3 decades. We visited with John last summer with hopes of being able to video the outstanding collection of historically significant stunt models that he and his dad have assembled over the years. We did get to video that collection, but we also had a chance to interview John from behind the camera and ask him how he got started in model airplane flying. Here's what he had to say. We're visiting this evening with John Davis in New Palestine, is it?
Yes.
Indiana, his home. And these are his 2 young men next to him. Could you care to introduce those to us?
This is my son Jeremy, and this is my son Jeff.
That's good to meet you guys. You guys fly at all? No. No? You hope to someday?
Yeah.
Yeah? Radio control or control line? Or a little of each? A little of each, yeah. John, you've been flying for an awful long time. I can remember when I was young seeing you fly at the Nationals and the various events, mostly in stunt flying events. When did you start flying model airplanes?
Actually, I began flying in 1959. My dad got me started in that, and first airplane I ever had was a little Cox profile PT-19. And then after that, graduated to building a scientific Kingpin, little half-A, and then moved on to a Vico Tomahawk with a Fox rocket. We always thought that at $11.95 the Fox 35 Stunt was a little bit too expensive to start off flying with, so we went with the rocket at a cheaper price. And then finally moved on to Noblers and Thunderbirds with Foxes in them, of course.
What was the first Nats that you attended?
The very first one I attended was in 1961. I was very lucky that I progressed so fast when I first started flying. I had my mentor was Charlie Licklider that helped me get started flying, and progressed very quickly from there.
And you entered several nationals after that point, didn't you?
Entered Nats from 61 through 66, and through schooling and the service and work didn't allow me to fly or participate the way I wanted to, so I didn't really get to fly anymore until about 1975.
And then you participated quite a bit through the 80s and even the 90s. Now you're back into flying again.
Right, right.
Mm-hmm. You've also participated at a number of FAI team trials, and of course it's been easy for you, and most of them, because they're right down the road here. They were for quite a while at Mount Comfort Airport, what, about 4 miles down the road?
Right, it was so close it was a sin to either miss them, or I either had a choice of paying my entry fee and flying in them, or I had to work at them. So I thought, well, flying is more fun than working.
That's not fair to have them that close where you can stay at home at night. What was your best Nats finish?
Actually, my best Nats finish was, as an adult in open, was in 1990 at the Vincennes Nats. I was lucky enough to win advance and win old time and half-A stunt.
This area here in Indiana is rich in stunt history. A number of very famous stunt flyers came from this area, and I know that a lot of them, as you had mentioned, were mentors and so forth. Could you tell us a little bit more about some of the people who helped you along?
Well, as I said before, one of my mentors was Charlie Licklider that got me started flying ballerinas and teaching me how to finish reasonably light and the proper way of sanding and building and finishing and even flying. And with that, also Bob Randall, who was a 1958 Open National Champion. Of course, Jack Sheeks was here, but in the meantime, he was kind of learning along with all of us too. And then there was Jimmy Varnholt, who won 60 Nats as junior, and 61 Nats also.
There was a pretty exclusive stunt club in this area, as I recall. Can you tell us something about that?
Right. That was another limited club membership that was only for people who had won the Nats or done well at it and was very serious about what they were doing, and that was called the Indy Stunt Masters. And it was limited membership, and there was only Charlie Licklider, Bob Randall, Jimmy Varnholt, and myself were the only members of that club.
Yeah, that's a pretty exclusive group, and a lot of heavy hitters in there too. I remember watching you fly in 1976 at the Nationals with an airplane of your own design called the Aero, and in that airplane you had retractable landing gear. I know you also flew that at the 75 Nats. Can you tell us a little bit about that?
Right. Those were two different airplanes. The 75 Nats airplane was the first one I built, and it was a built-up shark wing that had Goldberg retract system that had electric through the line to retract and lower the gear. It also had a removable wing and adjustable lead outs and wingtip box weight and all the good stuff at that time. The 76 airplane was a much lighter airplane. It had a Super Tiger 46 in it, and it flew much better. It unfortunately met its demise by having a foam leading edge and a build-up. The rest of the wing was built up, and with the retract system it had in it was a ROM air, and the access system to it leaked fuel through it and softened the foam, and the wing folded on it.
Your house is very famous, your garage is very famous for the collection of historical airplanes you have there. I know that there's one in there, a ballerina that you built, and a couple of your other Nationals airplanes, but there's also a number of very historical airplanes built by other modelers, very famous modelers. I'd like to go outside now and take a look at those if we might.
All right, let's do that.
Well, this is the John's Aero, this is the one you flew in 1975?
Correct. This is 1975 version. It's powered by a OS-40 H series. This is one that has a removable wing, and it also has the retractable landing gear. And this operated electric through the lines to a Goldberg servo that was mounted in here with mechanical retracts in it. Found that the centrifugal force was really rough on the going up side. Was the outboard gear had trouble going up. Sometimes it wouldn't go up till you turned into the reverse wing over. And when you lowered the gear, you usually had to wait till the engine quit, so the centrifugal force wouldn't keep the inboard gear from going down. But I found that even with the holes in the leading edge of the wing where the gear was, the airplane flew the same whether it had the gear up or down. It just looked different, that was all.
And with that unique profile, it really did look like an Aero in the air.
Right, it was pretty close to being exactly the same, upright or inverted.
Did you notice any detrimental effects from having that much side area below the center of gravity that far aft on the airplane?
Not really. The way that the aft part of the fins were made was with a lifting body on both surfaces of the rudder, and it really didn't seem to make any kind of rolling differences or anything.
I remember seeing it for the first time and saying, oh no, we have to deal with a retract airplane. And I think had you been more successful getting that to work that day, you would have given everybody a very hard time.
The problem with the gear, with the system itself, was weight. I never could figure out a way to get rid of the weight. There was seemingly no way of getting the thing under 5 ounces of system.
Well, that certainly is a beautiful airplane. Now let's go out, like we said, and talk about some of the other famous airplanes you have in your garage.
The airplane I'm holding right now is a Hummingbird, which was designed by Charlie Mackey back in 1960. I flew this thing at the Air Use State Championships in 1961 Nationals at Willow Grove, Pennsylvania. This one is powered by a Fox 19, and I'd won the Endurance portion of the contest. It was in 4 phases of endurance, beauty, speed, and aerobatics. It required to only have a 2-ounce fuel tank, and each time you flew it in any event you had to remove the needle valve, the pilot had to, and put it back in, and nobody else could set the needle. And this particular airplane flew 20 minutes and 40 seconds on 2 ounces of Fox Super Fuel. As a result, the head gasket melted completely down the side of the case. The airplane is finished in Aerogloss. It's held up reasonably well over the last 36 years, and it's one of my prized possessions. Some of you may have seen it in early aviation books of advertising from SIG. And this is one of the airplanes. This is a 1961 version of Jim Sohavy's Nobler. Jim had been qualified for the FAI team to go to Kiev, Russia with this. At 61 Nationals he was practicing, and the 3/32 push rod, elevator push rod, broke right in the middle and hit the ground and tore off the nose and the forward portion of the leading edge of the wing, all in one big chunk. My dad was collecting airplanes at the time, and earlier had suggested that Mr. Sohavy donate the airplane to his little museum that he was getting going. So Jim took the engine out of it and just gave it to my dad, and we took it home from Philadelphia. We got home a couple of weeks and got a call from Mr. Sohavy, and he said that his new Gypsy did not fly well, and he wanted the wreckage shipped back to him, and he would put it back together and go for the World Championships if he could get this airplane flying again. And so we boxed it up, sent it back to him. He put it all back together. It flew reasonably well. He enjoyed it, and he took it to Kiev, and I believe he came in second or third with it at that World Championship. The week after he came back, we got a box back with the airplane shipped back intact without the engine, of his engine, and so I thought that was pretty nice. So we've tried to keep it as well as we can over the last 35 years. This is the Charlie Mackey design carousel. It's the actual carousel that was published in the magazine. It originally was black. It was flown by Jimmy Varnholt, 1960 Nats in Dallas, and he won junior with this airplane. As soon as he came back from the Nats, everybody's getting problems about building his own airplane and everything. So he completely sanded the thing down and repainted it white as you see it now. It did look a little better, not a whole lot, but a little better at the time. When Jimmy flew this thing, it originally had wheel pants and the tricycle gear, and the white was much brighter then. And his typical flying style was that on a reverse wing over, he would come out inverted and rub the rudders on the ground. And it's been painted over several times, but the shape of the rudders have been ground down from the original. And it was quite a sight to see him do this stuff. And then when he'd pull back over on the upright side, he'd run the wheels on the ground. So he's a pretty flamboyant flyer at the time. The style then was to have real pointy wheel pants, pointy spinner, and wear these pointy toe shoes. And he fit the image perfectly. The airplane is a little different than some of these other airplanes that he used in Charlie's designs. He had a counterbalance flap on the outboard side that counteracted the movement of dipping of the wingtip on hard corners. The airplane was unusual. It had a high stabilizer and elevator compared to the wing thrust line, so the controls had to be whacked a little bit to make sure that they worked all right. So the essence in flying level, you would have about 10 degrees down flap and about 20 degrees down elevator just to fly level flight. So it got pretty interesting flying this airplane. This is a ballerina. This was the 3rd generation ballerina, and it was built from a kit that Charlie Licklider had come up with. He was the original designer of the ballerina, and this was his 3rd version. And in 1960, he decided to produce these in kit form. The entire kit cost $25, and it included everything except the engine and the prop and the spinner. Everything else was in the kit, including glue, paper, horns. The tank was already stainless steel tubing in it. Glue, like I said, canopy, controls, everything. It was all hand-selected contest balsa, and every one of them that was produced, which was only about 25 or 30 kits, all flew really good. This one, I flew at the 61 Nationals and came in third in junior with it. That was my first Nats. It's finished in aircraft dope. One thing about the airplane that I don't know whether people might be interested in, it flew better without the canopy. I don't know why. The trim on the airplane was just such that it just grooved much better without the canopy on it. So before every flight, the usual tactic was to start the airplane inverted, and then in the process, as you're taking the glow clips off, is to pull the canopy off, and when it flipped back over, nobody knew the difference because it was pretty much invisible. The airplane is made like Charlie's was, with the piano-style hinges, which really worked great. I hated cloth hinges, so these were a big advantage for me anyway. Plus, they were more of a sealed hinge than what I was doing before. The airplane's Fox 35 powered, of course. This is still the original prop on it. It weighed 41 ounces, and the first time I flew it after the Nats, I'd gone down to King Orange Internationals with it, and a guy offered me $1,000 for it to start off with, and that was pretty neat as a 14-year-old kid. And so this is one of my prized possessions. This is a Lou McFarlane designed shark. This particular one was made from the kit plans, not the kit wood, from 1965. Has a OS-35 old style stunt in it with a 9.6 Grish 3-blade on it. It weighed 50 ounces. It had 4-inch bell crank, heavy duty horns. They were all nylon bushed, and nylon hinges. And I flew it in team trials and got fourth with it at the time, the best I had ever done, and which was pretty good for me as a senior. And it's an excellent flying airplane, and I don't know what else to say. This is Bernie Ash design of an Aeron. This is the last remaining Aeron that he ever built from 1965. The original came out in 1960. It was a little smaller version, had a 52-inch span to it. This has a 56-inch span, but one thing remains the same of all the Aerons that he ever built. This is the exact same pair of landing gear, wheel pants, canopy, cockpit interior, stabilizer, elevator, and rudder assembly that was on every single one of these airplanes. He had a tendency to be a perfectionist, so everything on here is very well done. Some of the airplanes that he did construct never made it out of his basement when he was building these things, because he would get to the point where he'd build up to putting final coats of clear or final coats of color on and removing the tape, and it would start pulling off. He'd use aerogloss and it'd go down to the base, and he'd get so mad that he would just completely wad up the airplane, trash it, go out, burn the paint, and cool it for about a week or so, and then go back and start building again, the same thing. But this is the last remaining survivor of the Aeron series that he had made. This is a Jack Cheek design stunt liner. Actually, this is the second one he ever designed, and the one that was published in the magazine. The first one met its demise. This one actually flew in 1964 Nats down in Dallas, and had the event won, except on the landing the nose gear tire came off, so lost the points for that flight and lost the event. This was one of his many series of airplanes that Jack designed, typically with the I-beam wing. I think the downfall of the airplane, it had a double taper wing, and that just didn't work out real well with this particular design. One of the innovations he had was the upright engine. With the cockpit area, made room for the airflow to go through. It had a quick release system for the cowl that it was part of the antenna. Of course, the engine, the tank, everything else just slides out like normal. The airplane does fly pretty decent, considering. I had to weight it down as much as possible in the tail to get it to turn, and it still doesn't turn exactly good. It looks good in the air. It looks like an airliner in the air, and it's another one of these fun designs that he had.
Well, hello there again, and it's time for Engine Basics. I want to apologize for not being with you the last issue of Stunt Flyer Video Magazine, but we promised to make it up to you here. Well, at the end of the last installation we were together, we had measured the timing numbers on a Weber 32, and I have a fresh one here that's been worked over slightly by Randy Smith. I'm going to talk about that a little bit more. And what we're going to do is calculate just how much material we're going to take out of the top of the intake port in order to make the blowdown period correct for our use. And we're actually going to sit here and cut metal. This is, I guess, what you were waiting for after learning more than you ever wanted to know about using a timing wheel. And before we go on to do that, I really want to give you sort of a disclaimer here. What we're about to do here actually involves taking a Dremel tool, trusty weapon here, to expensive bits of metal. When I first started doing this, I messed up more than one or two pieces. So if you feel that you really can't afford to mess up a piece or don't want to, well, if you don't want to be blaming yourself for messing up, which is perfectly understandable and perfectly natural the first time you do this, you might want to consider allowing one of the better-known engine builders in the control line stunt market to do these same modifications for you. And as a matter of fact, if you do that, obviously a good shop will take responsibility for its own work. As I said, we actually bought this engine through Randy Smith at Aero Products, and he did a few things for us that I'd like to discuss. First, the engine bearings, the ball bearings in the front and back here, were changed for a better grade of bearing, and the front bearing was replaced with one with a rubber seal. The idea being to prevent leakage of base compression or crankcase compression out through the front of the engine. You've probably seen this a great many times, engines that spray fuel out the front bearing. Well, it has one small advantage. It means that you know that the front bearing is never going to rust. But on the other hand, base compression and base suction really are the pump that generates fuel draw in the engine. We depend on this in general with model airplane engines, but a stunt run critically depends on the quality of the fuel draw. So leakage out the front bearing will slowly degrade the running characteristics of the engine. And as a matter of fact, you can see in a lot of old style plain bearing engines or bushing type engines where the flyer has run not enough oil, or God forbid used some RC type fuel that had 15% synthetic oil in it and burned the bearings out of the engine. They spray lots of fuel out the front of the case, and the running characteristics just, well, they go away. We want to avoid that problem, and we had Randy Smith put a sealed bearing in here. The one thing he did not do for us that he generally does is change the intake timing, and that's because we're going to do that here. That's the part that we wanted to show you. Before I go on to this, when we parted at the end of last installation, you had a homework assignment. Yeah, that's what it was, homework. I had mine too. And let me tell you what I came up with. If you remember, the homework was to go measure as many engines as you could find. Intake timing, exhaust timing, crankshaft port timing. Almost all of the engines I looked at had crankshaft port timing of about 180 degrees, and they almost all were staggered 45 degrees from bottom dead center. This is a very typical number, and it's not a very critical number for stunt use. I think I said that the last time we were together. So don't worry about it. The two numbers that do matter to us are exhaust timing, and for engines that are useful as stunt engines, the useful range is as far as 145 degrees and as low as 130 degrees. Engines like the Super Tiger 60 or a Fox 35 tend to have an exhaust timing down close to 130 degrees. And some of the hotter engines are as far as 145 degrees, and we have to do something special to make those engines tame for stunt use. The intake timing is a fairly important number, not so much by itself, but because the difference between intake timing and exhaust timing is called the blowdown period. Actually, depending on who you talk to, the blowdown period is defined as half the difference between the exhaust timing and the intake timing. That's the definition I use. Blowdown periods vary, typically from 10 to 12 degrees, except when you are building a stunt run with an engine that has a very high timed exhaust, say like this engine, which was, I believe, 144 degrees. I've been modifying this type engine for use in stunt for a bit of a while now, and I typically run 7 or 8 degrees of blowdown. That's actually a very conservative figure, but when you combine it with the fairly radical exhaust timing of 144 degrees, it works very nicely. And that's the number we're going to use today. Next, we're going to sit down and calculate just how high we're going to raise that intake port. Yes, we're going to do some arithmetic. And in order to do that, I need to make some measurements on the engine, and that requires taking it apart. While we're taking this engine apart, I wanted to point out one or two really nice little features of this engine. Excuse me a moment. I get very paranoid about losing engine parts when I do this sort of thing, so I like to take a big piece of paper towel like this, or even a large Tupperware container for food, and put all the engine bits in it, because it's really annoying having to crawl under the workbench to find all the screws that you lost. One of the things, getting back to this engine, that makes this engine so nice for our uses in stunt are the little details. Weber really is to be commended here. This engine has a backplate with an O-ring seal. Let's see if you can see that there. Is that good? That O-ring seal is put in there to guarantee that base compression is not leaked out the back of the engine. And one of the most common problems of bad runs is the backplate of the engine has come loose. Okay. Another thing that you'll notice looking in this engine here is that this crankshaft has been marked. Randy Smith did actually check this engine for balance. It's nothing fancy. You really don't need to do that to get a decent running engine, but it runs a bit smoother. He did this when he changed the bearings. And pull the head off now. What we need to do is measure the stroke of the engine, and I'll explain that in a moment. First, let's get the head off. Your chapeau, monsieur. There we go. Okay, this is an ABC engine, and let's talk a little bit about disassembling engines in general. This is an ABC engine. That means that the piston should fit very, very tightly in about, the top 1/8 of an inch of its throw in the liner. So, especially with a new engine like this, I should be able to simply turn the crankshaft until the piston comes to the top and push the liner up out of the case just a little bit. Like I said, the piston should actually be an interference or squeak fit for about the top 1/8 of an inch. I should be able to just reach over and grab the liner and pull it out here real nice and easy like that. If your engine is older, has some caked up castor oil, what have you in there, you can actually lock that liner in there with baked oil and what have you. If it takes a little bit of physical effort, just a couple of words of warning. Number one, never grab the liner with a pair of pliers, either by the edge like this, or around here and squeeze on it. Don't ever do that. If you take the liner out of round, you'll just ruin the engine. And this is probably, aside from the crankshaft, the most expensive piece in the motor. If you really have a problem getting the liner out of the engine, turn the piston to bottom dead center and then take a plastic propeller. Okay, no wood, no steel, no brass even, but the tip of a plastic propeller, and stick it in the exhaust port and then turn by hand until you can push the liner up. The propeller will grab the top of the piston and the bottom and the top edge of the exhaust port, and you should be able to pull it out. Time for some arithmetic now. I have the engine disassembled so that I can measure the stroke, and I want to explain what it is we're going to be doing. The stroke of the engine, you'll notice I've drawn a circle here representing the path that the crank pin in here would travel. The stroke of the engine and the angle of blowdown that I'm going to put in this engine, which is a very conservative 7 degrees. It goes along with the very radical exhaust timing. This is a number that's based on my experience. Now, I've modified what must be close to 20 of these engines for myself and for other people, and this seems to be the good balance of horsepower and running characteristics. The 7-degree blowdown period and the stroke of this engine are going to give me a small dimension here that I'm going to use for the difference in height between the exhaust and intake ports in the cylinder liner. First, I have to measure the stroke. Now, if I had a ringed engine, I could leave the piston and the liner in the engine and just take a caliper like this one here with a depth gauge and put it into the engine at top dead center, butting this edge up against the top of the liner, and then do the same thing at bottom dead center and take the difference between the two readings. Problem here is, if I put this liner back in, remember this is an ABC engine. Remember I said a well-fit ABC engine will actually have a bind in the top? Well, when I try to do this now, I can measure the bottom very easily, but when I try to turn the piston to the top, it pushes the liner out of the engine, and I can't measure to that anymore. I'm going to make the same measurement, but I'm going to make it to the top of the crankcase. And that means I have to be very careful not to angle this caliper. So first, let's measure top dead center. And I place the engine at top dead center. Back the caliper down. And I get a reading of, that's 50 plus another 15, 65 thousandths of an inch, or 0.065 inches. Now to measure bottom dead center. And this number comes out to 0.705. Okay. 0.705 inches. Subtracting the 2, I get 0.64 inches of stroke. Now let's do some arithmetic. If I take the stroke, after all I want to find this triangle in here. If I take the stroke and divide it by 2, and then multiply by the sine of the 7-degree angle, and the sine of 7 degrees, I have a calculator here with a trigonometric function, is 0.119. Multiply those and I get a result of 38 thousandths of an inch, or just under a millimeter. Okay? So what we're going to do is we're going to cut the intake port until its top edge is 38 thousandths of an inch below the top edge of the exhaust port. Now, I said 38 thousandths of an inch, but quite frankly, it's really difficult to cut with a Dremel tool to within 5 thousandths of an inch. As a matter of fact, 10 thousandths is really about as accurate as I'm going to get. This is one of the places where it's easy to make a mistake. I've done all the arithmetic in thousandths of an inch, but you'll notice that who's kidding who. All right, now that we've got all the arithmetic done, set this aside, pull this piston out. Come on out, you. There. And time to mark the liner here. We know that we want to put a mark above each of these intake ports 38 thousandths below where the top of the exhaust port is here. In order to do that, I will take a magic marker. If I were in a machinist shop, I probably would have some Prussian blue or machinist bluing. I just paint a big wide stripe with the magic marker above each of these ports here. Okay. Now, while that dries so that I don't smudge it, I'm going to leave that there for a second, and let's talk about something here. You'll notice this liner has 3 intake ports, one directly across from the exhaust, and then 2 on the side, the main port and the 2 flank ports. There are differences of opinion as to whether to raise all 3 ports together, whether to raise just the 2 flank ports and leave the main port lower. And to be honest with you, every combination really works, but there are some reasons to do one or the other. First, this is an ABC engine. It's lapped, it has no ring. It would be very easy to raise all 3 ports, and as long as I'm careful about it and take all the burrs off the edges, and we have to do that before we put the piston in for the first time, or we can destroy the piston, we have no problem with the ring grabbing any of these ports, because there is none. On the other hand, if this were a ringed engine, we have to actually look at where the ring end gap sits. For example, on a lot of engines, the ring will be pinned so that the end gap rides up and down this little web between 2 of the intake ports. On some engines, the fact that the main port is very often angled, and let me estimate this angle here, the main intake port is very often angled about that steeply. And a lot of engines use this shallow angle here to guide the piston ring end gap so that it doesn't open up and catch an edge on the port. I believe, as a matter of fact, that the earlier ringed version of the Weber 32 does this. So on a Weber 32 with a ring in it, you definitely do not want to touch this middle port, unless you're going to be very, very careful about putting that shallow angle in there, and I don't think you want to bother with that. As a matter of fact, only because I started doing those engines this way, I'm still going to continue by raising just the flank ports and not touching the middle port. Why? Because I know it works nicely on this engine. There's another reason for that, though. Picture for a moment, it's time to play pantomime here. Picture for a moment that the exhaust port is facing the camera. The exhaust gases are coming out toward you. As the exhaust gases come out, they tend to suck the intake behind it. And the 2 flank ports being higher in the case, in the sleeve here, means that they will open up first and the flow will start to come in. And then last, the flow will come from the main port and catch these 2. What that does is it swirls the mixture in the combustion chamber. Swirling of the mixture in the combustion chamber is good because it mixes everything up. It guarantees that what little exhaust is left is mixed up properly so that it doesn't poison the reaction. And most importantly, it keeps you from blowing fuel straight out the exhaust port. Fuel economy, after all, does matter. So very often you will see the angled main port being lower down in the liner than the 2 side ports, and I kind of like that. It appeals to my sense of how things are supposed to work. All right, this should have dried enough now. First thing we're going to do is measure the height from the top of the liner to the top of the exhaust port. And in this engine, it is 550 and another 555, 0.555 inches. We're going to add 38 thousandths of an inch to that, and that is 0.593 inches. So I will set the caliper here to 0.593. And lock it down. And now very gently I'm just going to scribe the top of the port. And the scribe line, if it were just metal, I'd have to push very hard. But in the magic marker, I can get a real nice line with very little effort. Now, that's done. Let me hold this up to the camera so you can see. All right, there's the scribe line there, and there it shows up real nicely in the glint. All right, now, before I turn on the Dremel tool and make all kinds of noise, I want to pay attention to one more thing. I'm not going to touch this center port, like I said. The two side ports here are not cut straight into the case. Let me hold this so that you can see on the camera. They're not cut like this, at this angle. In fact, this one is cut with a little bit of an angle here, so the gases come in tangent. And the same is true on this side, on the front edge of that port, so that the gases are a little angled, like this. Okay? This is to promote that swirl. Once again, now, the gases in the side ports are coming up and pointed toward the exhaust. All right? Now, this is the part of the job where I take all of the nice engine bits that I don't want metal dust in, and if I had that Tupperware container that I typically use when I'm doing engine work, I would snap the lid on it. But in this case, I'm going to put it back in the box in its paper towel and set it aside, because this part of the job gets messy. And I've selected an 1/8 inch router bit with a very fine tooth on it. This is the type of tool that I typically use for this. What you want to do is go through the selection of bits in the hobby shop case there that Dremel has and actually get a selection of them. I find that I have round-tipped ones and pear-shaped ones for cutting on the aluminum in the engine, which we're not going to do today. But I have a collection of different diameter straight mills like this. And the one with the fine teeth I think is very good for cutting on the liner because it leaves a nice smooth edge, if you're careful, of course. All right. Now, time to make some noise. And this process of actually cutting on the metal in the engine typically takes me about 20 minutes to do very carefully. I avoid coffee. But I take breaks often and inspect my work, trying to take care that I don't make a mistake, because we have lots of cutting off tools. We don't have any putting back on tools. If I go too far, oops, and we throw away the part and we call up Randy or someone at Horizon Hobbies and order new parts for a Webra, and that takes time and you don't want to do that. Once again, I'm going to pay attention That doesn't work. Once again, I'm going to pay very close attention to maintain the angle of the port, not just up and down like this, but the angle of the port into the engine. As I said, this tangent angle here. Not where it comes in square, but comes in at a sort of tangent. I like this part. let's stop and check part way here. I'll just take this X-Acto knife and just knock the big edge off so that I can see how close to my scribe line I've gotten. Now, I don't know if you can see this on camera very well, but I've almost touched the line here, and I've got a little bit more distance to go. And I haven't done too badly at keeping the angles on the edges of the port here. Well, keep cutting. And as I look at this, I think I've cut this one port just enough. It's right on the line all the way across, and if I say so myself, I think I've done a decent job of maintaining the angles. Now I very calmly tell you, repeat on the other side, and like I said, we'll leave the middle guy alone. And once that's done, we'll be back to talk about dressing the edges of the ports so that you don't mess up the piston when you put it in. It's very possible, especially with a plated engine, one with a chrome or a nickel plating on the liner, to leave ugly edges on the port that will flake eventually, and you don't want that to happen. So we'll be back after I finish doing this other port. Okay, let's give this a good looking over. And in order to do that, the first thing I need to do is wipe our poor man's bluing off. Almost any solvent will do. I just used a little bit of zip kicker there. And all clean. Now, there are a variety of different deburring tools you could use. You see all that brass dust there. By the way, I should mention this. I wear glasses, but for those of you that don't use safety glasses, okay, a piece of brass or chrome filing stuck in your eye would really hurt. And like I said, we at Stunt Flyer Video Magazine really kind of like to have our readers around. Readers? Viewers? What do we call you? Anyway. Okay, look at this here. What we want to do is deburr, and my favorite deburring tool is a nice, clean, sharp X-Acto knife. If you can get a hold of a real fine Arkansas stone, preferably a skinny one, that's a real nice tool for using. But any stone that's coarser than an Arkansas stone is likely not going to do you very well and will leave all sorts of gouges in the edge that will catch on the piston. Resist the temptation at this stage of the game to get the piston out of the box and put it in the liner. Until we deburr it very carefully, and we'll use our fingernail to test, you run the risk of scratching the piston. What I like to do first is just take the big ugly edges off the outside. And while these are not critical to the running of the engine, you will find out that it's a real easy way to get the cylinder liner stuck in the case if you have a burr left on the outside. Since it's not a critical fit, like I said, you can put a real nice chamfer on these and take a lot of material away. But I like to get this out of the way early on. You'll also see that with a lot of brass or other liner materials that you can actually cut little slivers with the X-Acto knife. And that's the reason you want a sharp one. It won't stay sharp long, but and as a matter of fact, we might go through a couple of blades doing this. Okay, they feel nice and smooth on the outside. Now let's concentrate on the important place. I like to take the knife and just run it very gently. I'm trying not to take too much material away, but run it very gently at an angle all the way around, trying to make a nice smooth cut, not letting the knife catch and jag all along the port. Can you see that here? And what I'll do is I'll just keep running the knife back and forth real gently, trying to make sure that I don't nick the inside of the liner with the tip of the knife. It's easier to do than you think. And I will keep running around the edge of the port, trying to put a real small 45-degree chamfer on these edges here, like this. Do that to the other port. Wipe all the nasty stuff out of there. And take a paper towel to this. Clean this out real thoroughly. And the next thing I'm going to do is hold this liner up to the light and just look for burrs that I can see. I'll hold it up to this light bulb that's off in the distance here, and I will let the light that shines off the bottom edge, you see a bright line, and you can't see that on camera, I'm afraid, but there'll be a bright line that shows up on the bottom, and if you slowly turn the liner, that bright line will allow you to see any little flaw that lines up with it. And then go to the other port. Okay, I think this is ready for the next test. I should mention at this point, as if you didn't know already, there's no such thing in a workshop as too much light. And a really nice bright light bulb would be real handy. For doing engine work, I typically have one of these burger joint French fry lamps. At least that's what I call it. It's a halogen lamp with 250 watts that stands on a pole just above my workbench. And I put it a foot or two away from my work. Not only does it allow me to see really well, but I get a real good suntan when I'm working with it. Okay, the next test uses one of the most sensitive things in the world, your hands. First, I like to take the edge of a nail, and on a small engine like a 32, I have to use my pinky, and just gently run it along the liner past the edge of the port. I don't know if you can see that on the camera. Run that in there. You see where I'm just running it to catch the edge of the port? The idea is I want to make sure that my fingernail won't catch anywhere. And that's what I'm doing. I'm looking for an edge that will catch my finger, both top and bottom. Because if I slip with the Dremel tool, I could have put a burr on the bottom edge. I don't feel any in that port. Let's do this here. You'd be amazed at how tiny an edge will catch on your fingernail. Okay, and I don't feel any with my bare finger. Well, sounds to me like it's time to clean this up really carefully. Clean all this metal dust up off the table because I'm going to reassemble the engine in a second right now. And two things require sterile conditions: surgery and engine assembly. All right, I've got a rag here with some solvent on it, alcohol, whatever. I just want to make sure that I get every last little bit of that metal dust out of here. And I will run it down the center of the liner. And make sure that I've cleaned the edges of the ports up. Okay. And set that aside. I don't want that to attack the table. And let's rescue the rest of the engine. Time to reassemble. All right. With the piston and the liner dry, I'm not going to push on them at all, okay? I don't want to risk, if I did leave a burr in there, scratching things. I want to use the piston as a last test to make sure that I got everything clean in the liner. I'm going to put these two together and make sure that they fit nicely. And like I said, I'm just going to let gravity do the trick. The long skirt here is on the exhaust side. And it very gently just slides right past the port. That's good. Okay, time to get some after run oil here. Stuff. Almost any oil will work as an after run or for an assembly oil. I tend to use Mobil 1 only because it's cheap and it's available and it doesn't attack the silicone rubber in the fuel system of our model airplanes. Marvel Mystery Oil, even 3-in-1 if you really need to do that. And I'm just going to put a little bit on the piston here. Swab that round. Okay, lightly oil the outside of the liner so it slips into the case a little bit better. And things to check for when you assemble the engine. This engine here requires that you put the piston in and the connecting rod with the sleeve out and then slide the sleeve over it. That's common of almost any engine where the front does not remove. Number one, you'll notice that the piston here has a long skirt on one side. That long skirt goes on the exhaust side of the engine. And the second thing you'll notice is looking at the bottom of the connecting rod, one side of the rod here will have usually a fairly sharp corner in the edge, where the other side of the rod will have a very pronounced chamfer. Okay, there'll be a real taper to that corner there. That chamfered edge should go to the front. So that's the front of the engine. That's the exhaust side. Sure enough, this rod and piston are assembled in the right direction. The consequences are not too dire if you put it together backwards, but the bottom of the connecting rod will get less oil than it should get, and it might wear prematurely. Slide that together. Push this up top. And now being careful not to jam things like a drawer put in cocked. Put the liner down there and pay a little extra attention to get the exhaust port centered in the side of the engine. And we're looking very good. Okay, one of the things that we did or didn't do is we did not cut the aluminum of the crankcase to make the bypass passages here in the front and in the back, to make them match up to our raised exhaust intake ports. If you're interested in every last RPM from the engine, you can do that. But if you're going to do that, first you have to heat up the crankcase and take the bearings out. Okay, because any metal dust, any aluminum dust that ends up in the bearings will destroy them the first time you run the engine. As a matter of fact, how about a promise? Next time we're together for Engine Basics, we're going to talk about how to replace the bearings in your engine. I think that would be a very good subject. Getting back to the passages here, the mating of the aluminum cutout to the port. We took very little material off of the liner, actually. We only took about a 32nd of an inch or so, maybe a little bit more than that in this size engine, to make everything line, to make all the timing numbers be what we want. The lineup of the ports is not that bad with the aluminum bypassages. As it turns out, very often when an engine comes from the factory, these passages don't line up very well with the ports in the liner anyway. Weber happens to be one of those manufacturers that does a pretty good job to begin with. But what you'll find out is that there is a very, very small horsepower price we pay for doing this, and I don't think you're going to be able to tell the difference in the way the engine runs. So for this kind of modification, I don't bother. If I'm out building a racing engine, yes, I do actually take a scribe, a right angle scribe, and I will reach into the engine and hook the scribe on the top edge of the port and put a very gentle scribe line in the aluminum of the crankcase. Then I'll pull the liner back out of the engine, and by the way, the liner will try to jam on the tiny little aluminum raised by that scribe. It's a real pain to get the liner back out. And then I'll actually take a ball-ended Dremel bit and go in there very carefully, try and smooth up the top of that passage, making it both round and lined up with the scribe line. That's a lot of effort, and like I said, the first thing you have to do is take the bearings and everything out of the crankcase. It's really not worth it for what we're doing here. This engine doesn't have a head gasket. They rely on the machining of the head. And we're going to very gently snug down the head. I like to hold it down, just snug one screw, just snug the screw down across from it. And now that it's just barely snugged, I very gently crisscrossing back and forth across the engine, very gently. Most engines, larger engines certainly, have 6 head bolts. And what you try to do when you tighten up 6 head bolts is to work in a pattern that always goes as far across the head as you can, where you never tighten 2 adjacent screws one after the other. The idea is to keep from warping the head. Now obviously with 4 head screws I can't avoid doing 2 next to each other. There just isn't enough there. And I keep doing this, gradually tightening more and more each time until I finally snug them up real good. Okay. And pop the back plate on. You'll notice here the back plate has a flat spot. The flat spot goes pretty much toward the top, and the reason it's there is so that when the engine is at bottom dead center, do you see this corner of the piston here? This is that long skirt that makes sure that the exhaust never uncovers. That long skirt, if the back plate were completely round, would hit here. So they just put that little relief there so that we don't have that problem. So make sure that it goes the right place, otherwise the engine's going to hurt itself. There's that O-ring seal, which is such a nice feature. Now, save for a Venturi, this engine is completely assembled. Talk very briefly about the choice of Venturi here. There are several places that you can buy a Venturi for this engine aftermarket because of course it came with an RC type carburetor. A 32 sized engine like this one, I usually like to put a 0.275 inch to 0.285 inch diameter Venturi in it. And when I give a Venturi size like that, I usually use a Super Tiger needle valve, which is a 4mm diameter bar, so it blocks off a portion of the middle. That's equivalent to a straight through Venturi using a spray bar in the back here through the drawbar hole. of about 160 to 165 thousandths of an inch, 0.165 inches. Venturis like this you can make yourself if you have a lathe, or once again, go to one of the engine builders in the area that does this kind of work. In our case, I'm actually going to call Randy Smith myself and order a 160 sized Venturi for this engine because it's going in my test bed. But, well, let's see, that just about completes the job. We have an engine with raised intake timing, and I think this will work very nicely in my profile. Anyway, next time we see each other, we'll talk about bearing replacement, and until then, fly stunt.
Control Specialties Corporation has been producing the very best CL Stunt control system hardware since 1974. Their latest line of strong arm control horns follows in that tradition. These components were professionally designed by James A. Hunt, a certified manufacturing engineer, who's also a lifelong modeler. CST strong arm control horns are available with 3/32 or 1/8 inch diameter shafts. Precision machined brass bushings are staked between the steel uprights, and the uprights are then silver brazed to the output shaft. The flap horns feature 3 brass bearings, while the elevator horns have only 2. These bearings are located in the normal positions on the steel uprights to allow for popular control throw adjustments. Brass tubing horn wire bearings are supplied with each horn, and these are designed to be anchored to the trailing edge of the wing or stabilizer with supplied brass retainer clips, which are precision formed to center the horn properly on the fixed surface. You can order CSC strong arm control horns with the shafts bent, or you can purchase them unbent so that they can be custom fit to your new model. For pricing and further information, please contact Control Specialties Corporation at the address and phone number shown. Rodak Manufacturing is pleased to announce the release of their Profile Oriental Kit. This design features the classic fuselage profile shape of D. Rice's very popular full-body Oriental, but is much easier to build. The kit features die-cut and machine-cut selected balsa and plywood parts. The fuselage is precision pin-routed for accuracy. All balsa and plywood necessary to complete this kit is included. Formed music wire landing gear is supplied, along with all of the other wire parts. The Profile Oriental Kit features a complete hardware package which contains all the necessary screws and bolts, split sleeve couplers, copper wrapping wire, push rod retainers, nylon control horns, hinge material, landing gear straps, adjustable tank brackets, a 3-inch nylon bell crank, a tip weight box, an adjustable lead-out assembly, and much more. Full-size rolled plans are included, as is a comprehensive photo-illustrated instruction manual. A special lineup sheet and decals are also included. The Profile Oriental is designed to accept engines from 35 to 46 size, has a length of 35.5 inches, a wingspan of 55 inches, and a wing area of 555 square inches. For more information about the Profile Oriental Kit, please contact Rodak Manufacturing at the address and phone number shown. Hi, and welcome to Shop Shorts, Stunt Flyer Video Magazine's newest feature. This segment will be dedicated to making your life easier in the shop. We're going to cover some building techniques, but mostly just some of the ways of making sure your tools are more organized, making some special tools for specific purposes. In general, just ways of making your life easier in the shop. Before me, you see one of the problems that many modelers face, and that is how to organize small pointy tools, needle files, scribers, screwdrivers, and ball drivers. We all have these. They're all necessary parts of our model building. But keeping them organized and being able to get to the tool you want right away is difficult. I've devised a method I think works pretty well, and I want to share it with you. This method starts out with common expanded polystyrene foam. I prefer to use 2-pound density, 4-inch thick foam because I use this type of foam for the lost foam wing fixtures that we make for SkyTech Innovations. We start by laying out a block of foam that's large enough to accommodate all of the tools we have to put in it, and I like to use a 1-inch grid. So I'm going to make this block 7 inches wide by 9 inches long. This is the bench where we do all of the blanking for the SkyTech Innovations lost foam wing cradles. We're going to cut this piece of foam here. As you notice, there is a perpendicular bar of metal, actually aluminum, on either end of this bench. And using this 48-inch long bow and our power supply, we can line up the marks we made and slice straight down through without the need to have to pin any additional templates to the foam. By having this cutting bench set up all of the time, I can cut foam at a moment's notice and cut very accurate perpendicular pieces. We're cutting with 1.5 ohms per foot resistance wire. This is nichrome wire, and wire like this is available from the Driver Harris Company in Harrison, New Jersey. You can buy this wire in 1,000-foot rolls fairly inexpensively. So if you're inclined to cut foam wings or lost foam wings, or just to do a lot of foam work for fixtures or templates and so forth, like we're doing right here, you can get the nichrome wire in quantity and not have to spend a lot of money for it. Okay, now this block is cut to size. Now let's go back to the bench and lay it out for the various for the grid work for the various tools we're going to put in here. Once we have the outlines of our block cut to size, then it's time to lay out the grid pattern on the surface of the foam. We grid the block in one direction in 1-inch grids. And we use a combination square to ensure that we're drawing perpendicular to one edge of the block. The next step is to lay out the grid pattern in the other direction. And again, we're using 1-inch grids, so each end of the block will have to be marked in 1-inch increments. And then we connect those marks, forming a grid work. When the grid is completed, this is what the block should look like. The next step is the fun part, and it's the easiest part. You have to decide at the intersection of each grid which item you want to put there. In this case, I'm going to line up all of my needle files on one end of the block. And if you do this neatly, take your time, this will be a rather neat looking little device. Even the square-edged or square-ended needle files can be accommodated here. You will, in some cases, actually rip the foam up a little bit trying to get a square end device in, so it probably would pay to take a tool with a pointed end and start a hole for that needle file, the square-ended needle file. In this case, we'll do that here too. Matter of fact, let's start a bunch of holes using the pointed tool. I also like to store my larger files in a block like this, and they can be stored in the same block. Again, use a more pointed end tool to start a hole for something that has a more square tang on it. And by twisting, it tends to seat itself in the foam a little easier. Here's a couple of more needle files I missed. And again, almost all of your pointed tool devices can be stored in this block. We can even put screwdrivers. Start screwed down at one end here. And obviously, once one of these is filled up and you have more tools to store, you simply make another one. It's really nice for holding ball end drivers and tools of that sort. And of course, the tools you use most often should be stored near the edge so they're easier to find, get to them quicker. Well, there you have it. I have two complete lines of grid work here yet to fill, and I'll find some tools to put in there, I'm sure. But there's a quick way to neatly organize and store all of your pointed tools, your needle files and your screwdrivers, and scribers and that sort of thing.